Okay, welcome everybody. I'm Jim Knoll. I'm the Tucson Amateur Astronomy Association Star Party Manager, and welcome to our virtual star party. All right, so here we are with the current position of the planets for June. And if you look, you can kind of see Earth up here. Mercury's right in line with us and the sun, so it's actually down behind it's going to be in the glare of the sun. Venus is pretty close to the sun, so it's probably not going to be visible, very visible. Mars is right out here, and it's in good shape. It's going to be in the western sky. And as we zoom out, you can see there's Jupiter and Saturn. They'll be up pretty late. Jupiter rises. Let's see, Jupiter rises around midnight and Saturn about 11 p.m. Arizona time. So those are going to be pretty late objects. And then if we keep going out, we've got Uranus, Neptune, and then poor little Pluto out here. Pluto was demoted several years ago to a dwarf planet. And as you can see, if you compare the orbits of the other planets to Pluto, you can see that it's a little bit elongated, a little bit different. And then if we start looking at the view from the edge, then you can really see a difference between the main planets and Pluto. Most of the planets orbit in the same plane as the sun, whereas Pluto is often in a slightly different elliptical orbit. So Pluto, they think, is probably one of the larger objects and one of the ones we've seen at the closest one for the Kuiper belt. So the Kuiper belt is just kind of a belt of leftover stuff from the solar system formation beyond Pluto. And Pluto is just one of the Kuiper belt objects. Once we get the James Webb telescope up later this year, then hopefully they'll be able to start finding some more really cool stuff out in the Kuiper belt. So let's, and then right now in the night sky, here is our current view of the night sky. And if you look evening, after dark or so, if you look down towards the southeast, you can see Scorpius right down here. It's one of the few constellations that actually does look like a scorpion. Straight overhead, pretty much, is going to be Virgo the maiden, and it'll be pretty much straight up. And there's a lot of things, and we'll probably look at some of those at some point in time. And then off towards the west, just west of Virgo, you can see Leo the lion. You can see the lion outlined here. Leo is actually kind of easy to find in the night sky, at least the main, because what you can look for is you look for a backwards question mark right in here. So kind of look straight up and you'll see a backwards question mark. This bright star right here is Regulus. And then this is the name of the lion. And then the rest of the lion right now is kind of pointing towards the east. And then looking up towards the north, you can see Ursa Major, which is the big bear. That's this guy right here. Part of the big bear is the Big Dipper. So you can see the handle of the Big Dipper right here, which is the tail of the bear. And then the bucket is kind of the main part of the torso, and then his legs come off the lower end of the bucket stars. And then there's kind of a faint star out here that denotes his head, and it kind of stretches out there. The cool thing about the Big Dipper is you can use it to actually help you find the North Star and the Little Dipper. So if you go off these two end stars right here of the bucket, they'll point right towards Polaris. Polaris will be the bright star that's out here. And that's the end of the handle of the Little Dipper and of the Little Bear. Here's the outline of the bear. It's a little bit hard to see because it's kind of crowded in there. The handle for Ursa Minor, the Little Bear, is the handle of the Little Dipper is part of Ursa Minor. It's the tail. And then the bucket part is right in here. Most people can only see Polaris and maybe these two end stars. If you can see the other stars in the handle and the Little Dipper, then you've got actually some pretty good skies. Now, one of the things we're going to talk about tonight is we're going to take a look at several different kinds of galaxies. And so I wanted to make sure that you guys could had a little idea of what they were all about. So there's basically three main types of galaxies. There's spiral galaxies, elliptical galaxies, and then what we call irregular galaxies. We'll probably look at several spiral galaxies. They're really cool because they have some very well-defined spiral arms, a nice clear nucleus in the center, very pretty to look at. They're also kind of medium-sized to somewhat large, but mostly medium-sized galaxies. They can be small to to only a few billion stars to maybe several hundred billion stars. Our Milky Way galaxy is a spiral galaxy, probably looks very similar to this, as is the Andromeda galaxy, which is the other large galaxy near us. Then we have elliptical galaxies. Elliptical galaxies, they think, are kind of the result of maybe mergers of lots of other galaxies to include spiral galaxies. And they basically just kind of get all jumbled up into a big ball. So they don't have the defined structure that you would see in a spiral galaxy, but you have just kind of a ball. They're huge. They can have upwards of trillions of stars because they've been formed by a lot of mergers of previous galaxies. The current thought right now is the Milky Way and the Andromeda galaxy would probably merge together in 4 to 5 billion years. When we do, we might form an elliptical galaxy because it'll just kind of take all the spiral arms and jumble everything up. Then we have irregular galaxies, and there's a couple of types. There's ones that are called lenticular galaxies, so they kind of stretched out. Some of them could be spiral galaxies that we're just seeing the edge on. Some of them aren't, but right in here you can see, and this is called the sombrero galaxy. It kind of looks like a sombrero hat. This would be the brim of the hat with the top and bottom part of the hat. So that's one type of galaxy, of irregular galaxy. And then another one, type 2 one, is when two galaxies collide. So when they're first starting to merge, they might stretch each other out and do some weird things to the stars and the dust and the gas. And that makes them just look kind of irregular. And this is the picture here is the antenna galaxy. And then the other thing that we're going to look a little bit at tonight is the evolution of stars. All the stars generally start with out of a cloud of cold hydrogen gas. The smaller stars, like our sun, will eventually, when they're on the main sequence, they'll last for 10 billion years on average or so. And then when they get towards the end of their life, they will start puffing off their gas, and they kind of expand out into what's called a red giant. So they'll get a lot bigger, but they're also a lot more diffuse, and the mass is still the same. They're just larger. And then eventually they'll puff off their outer gas, and that's what you see coming off of here, and that we call a planetary nebula. And then finally, what will be left will be kind of the core of the star, and that's a white dwarf. So this will be the fate of the sun in a long, long time. We don't have to worry about it for any time soon. It's going to be at least another 4 or 5 billion years, a long ways. And then the larger stars, like Betelgeuse and some of those, will become red supergiants. So they'll start off on their main sequence, but they may only last for millions of years, not billions of years. And then they become a red supergiant. So it's similar to a red giant, just much, much larger. And then finally, they will explode and become a supernova. And sometimes we can look at supernova remnants, and that's the gas that is expanded off of these red giant supergiants after they've exploded. And then they'll either become a neutron star, so they're just kind of they're much, much smaller than what they were before, and they're just very dense neutrons. Or if they're really big, then they could become condensed down into a stellar mass black hole. So this isn't the supermassive black holes that we have in the center of the galaxy, but these are more stellar or star-sized black holes. So we'll see some of those kinds of objects probably over tonight as well. All right, the last thing I want to briefly mention before we get into doing some observing is a little bit on astronomy terms. Throughout the program, you'll hear us refer to object as a Messier or M number. Those are objects that were recorded by Charles Messier back in the 1700s as he was looking for comets. And he noticed these things didn't move, but they kind of looked like comets because they were fuzzy. And so he chose to record them so that he wouldn't confuse them with future observations. And they've now become some of the best objects for amateurs to view. Well, also another large catalog that we use is the New General Catalog, or NGC. So you'll hear us refer to NGC numbers as well. You will talk a little bit about magnitudes. The lower the number, the brighter the object. Normally a magnitude 6 or a little lower than that, maybe a 5 is naked eye. So that means it's something you can see with your naked eye. If it's a higher number than 6, then you probably need a telescope or binoculars. And then finally, a light year. Light year is a distance that light travels in 1 year. So at 186,000 miles per second, that's about 6 trillion miles per year, or about 9.5 trillion kilometers. It's so we use this to measure distance between objects. Now what we're going to do is take a look at some of the astronomer's equipment. We'll start off with Jim O'Connor. Jim.
Thanks, Jim. What you're seeing in front of there is exactly where I'm sitting right now, except it's nicely a bit darker. My equipment starts out with a 10-inch Schmidt-Cassegrain telescope. But rather than using an eyepiece in it, I've put a video camera on the back end. That telescope, and you can see it farther away on the left and up close and personal on the right. It's a very old one. It's almost 30 years old, so I've got a new, rather newer mount it's on, the thing that holds it up and lets it move around the sky. It's a Celestron AVX equatorial mount. So it's a 10-inch Schmidt-Cassegrain telescope on an equatorial mount. The camera is called a Mellencamp Terminator. It's got a high sensitivity CCD. It's one of the highest sensitivity video chips in the world, but it's small. It's only 1/4 of an inch on a side, that chip. So it's only got 377,000 pixels. So it does not give you a whole lot of grabbing of light, but it can go a long way away and grab it. It's in full color, and it's got a thermoelectric cooler on the inside. And that's what if you look closely at the camera, you see these big fans on the outside. That's keeping it cool. But that whole setup is what I use when I go out and show things. And if you look in the left-hand picture, there is a monitor on a stand. That monitor is what I use for public viewing, because more people can see what I'm looking at, and then I know what they're seeing. Jim?
Okay, thank you. And now over to Rick.
You'll see that my scope is of a different design than Jim's. Mine is a refractor telescope, uses lenses rather than mirrors. It's a 4-inch stellar view refractor on a very large Losmandy G11 mount. Gives me very good stability for imaging. And I'm running an ASI 2600 color cooled camera. The sensor inside this camera has been specially adapted for this service, but it's very similar to what you would find inside a modern digital SLR camera.
All right, thanks, Rick. And Bernie?
Hi, everybody. My name is Bernie Stenger, and I'm another member of the Tucson Amateur Astronomy Association here in Tucson, Arizona. This evening, I'm out at our dark sky site near the Chiricahua Mountains in the southeast corner of the state. The telescope I'm using is this telescope you can see in the image right now that I took as I assembled it just prior to the viewing this evening. And this is a Celestron 8-inch telescope on a Celestron AVX mount. Now, instead of having the camera that I'm going to be using mounted in the back end, it's actually mounted in the front. So let me show you how that works. This was prior to assembly of the front end. This is the Malincam DS10C thermoelectric cooled camera that I'll be using this evening. And it's mounted onto what's called a hyperstar lens. This particular assembly in the front of the telescope and the camera actually look back in this direction towards the mirror at the bottom of the telescope. So light comes in, bounces off the mirror in the back, and then comes up through this lens and into the camera. This allows me to operate at f1.9, which means it's very fast, it's very sensitive to light, and it has a nice wide field of view. So my first object tonight is actually something quite special, especially for those of you who are in the Northern Hemisphere, above around 35 degrees north, which is pretty much most of the United States and Canada. What I have tonight to show you is Gamma Crux, which is the northernmost star of the Southern Cross. So let me bring that up. Okay, this very bright star right here on the center left is Gamma Crux. It's not only the northernmost star of the Southern Cross, of course, it's the northernmost star for us as well. And it's a very difficult star to capture because it only rises less than a degree above the horizon. And it's for about an hour down here in southern Arizona. It's a magnitude 1.6 star. Crux is the smallest of all of the constellations, the 88 constellations. You can't see the whole constellation from here, but the other three stars are to the left, to the right, and below. And of course, they're below the horizon, so you can't see them. Gamma Crux is 88 light years away. And it is a G-type star, which is a star similar to ours, our sun. In fact, it is the closest G-type star to our sun. And if you look closely, it does have kind of a yellowish, reddish yellowish appearance. Now you'll probably notice this kind of silhouette in the background, and that's actually the horizon here in southern Tucson where I'm located. That's a mountain about 15 miles away or so. And this fuzziness to the right, I don't know if you can see that, but that's a bush in the foreground, and it's going to start eclipsing the star here fairly soon. So you might see it dimming in and out because of that. The Southern Cross is quite a famous constellation. It's on several national flags of southern nations and is part of many, many songs as well. One I particularly remember, and I'm going to show my age here, is the song Southern Cross by Crosby, Stills and Nash. And they sung that in 1981. That's when it was released. So Gamma Crux.
Wow, that is that's a treat, Bernie, to be able to see that, especially even for us here in Southern Arizona, but especially for anyone that, like you said, is north of us and whatnot, to be able to see something that's really primarily visible to those in the Southern Hemisphere.
Yeah, I wish we were just a little bit further south. We could also show Alpha Centauri, but unfortunately, even here, Alpha Centauri is just too far down below the horizon. And there goes a satellite right there. You can see just a little tiny one, kind of skirting the horizon off in the distance. My next object is Omega Centauri. Those of you who watched last year might remember that I had Omega Centauri in my observations as well, but it's such a beautiful, beautiful globular cluster that I can't help but show it again a second time. So we're going to go back to Omega Centauri. Omega Centauri is also known as NGC 5139. It doesn't have a Messier or M number. Many people wonder why it wouldn't have a Messier number, since it's so bright and so obvious. You can see it with the naked eye in a dark location on a clear night. It shows up as a fuzzy patch to the south, down close to the horizon, at least in southern Arizona. Again, those in the northern sections of the country in Canada can't see Omega Centauri. And it's the reason why Messier didn't put it on his list. From France, it just wasn't visible. It was discovered by Edmund Halley in 1677. But there's actually references to it in old texts of Ptolemy as far back as 150 AD. It's the largest globular in our galaxy at a distance of 17,000 light years. It's about 150 light years in diameter. It's much larger than other globulars. If I placed another of the many globulars of the Milky Way next to this, it would look very, very small in comparison. There's about 10 million stars within Omega Centauri, and it's been aged at approximately 17 billion years old. You can tell they're old stars because they have a yellowish cast. There's many, many very old red giants within the globular itself. The theory on the origin of Omega Centauri is that it's most likely a disrupted dwarf galaxy. In other words, it was long ago a dwarf galaxy that possibly orbited around the Milky Way, but eventually fell into the Milky Way and got stripped of its arms and left only the central core. So most likely, according to current theory, what we're looking at is the central core of that old dwarf galaxy. These stars are so compact and so densely connected or near each other that they are literally almost on top of each other. And they've been measured at only 0.1 light years apart. Now, to put that in perspective, our nearest star to us, Alpha Centauri, is 4.5 light years away. And it looks like a bright star in the sky. Can you imagine another star, not our sun, but another star 0.1 light years away from us? It would look like a very bright star, a very, very bright star. In fact, if the sky was full of them, most likely there'd never be darkness on Earth, even at night or during our so-called night period. It would still be very, very bright out, with the sky covered with full moons, so to speak. Jim?
Yeah, I never ever get tired of looking at Omega Centauri. When we're at the Grand Canyon, where I usually set up, I'm able to just barely get it above the visitor center roof line. So it's still, you know, even up at 7,000 feet, of course, you're a little bit higher up in latitude at the Grand Canyon, but at, you know, it's still just barely coming over the horizon for us up there. But yeah, it's a phenomenal sight. You think back to the fact that it's probably the core of a galaxy, like you said, that merged with us a long time ago. Pretty amazing. Great stuff.
So what we're looking at here, everyone, is known as the Iris Nebula. This is a small nebula located in the Cepheus constellation. It's about 1,400 light years away from us. And what you're seeing, the main part of the nebula is about 7 light years across. Now you'll notice, you'll see this bright star and then this bright area of nebulosity around it. And then you'll see kind of dark areas where you don't see many stars. That's because although it's not coming out in this picture, there's dark lanes of dust surrounding this nebula. It's known as the, again, it's known as the Iris Nebula. It's also known under its catalog number of NGC 7023. It's that star in the middle is a hot young star and it's still forming. There's also a open cluster of stars located around this nebula. There are central filaments of cosmic dust that glow with a reddish photoluminescence as some dust grains convert the star's invisible ultraviolet radiation into visible red light. Yet the dominant color of this nebula is blue, which you're kind of seeing the blue here in the image.
My next object is M63, or what's also known as the Sunflower Galaxy. Sunflower Galaxy is a small galaxy. It isn't as large as the Milky Way. And it's in the constellation Canis Venatici. It was discovered by Charles Messier in June of 1779, and he put it on his list of objects as number 63. Now you'll remember with a discussion of the Messier objects, Messier was looking for comets, and he was finding fuzzy patches in the sky that didn't move. So he assumed that was not a comet, put it on his list, and moved on. He really didn't know what they were. To him, they were just fuzzy patches. And with his little telescope, he probably couldn't resolve it into anything more than a fuzzy patch anyway. That honor went to Lord Rosse in the mid 1800s. With a larger scope, he was able to resolve it into a spiraling galaxy. So if I zoom in on it, you can see there's a very bright central core, but it has kind of diffuse spiraling arms. They aren't clear arms, they're kind of diffuse arms. And that's one of the reasons why it has the name the Sunflower Galaxy, because it looks like, if you've seen a sunflower, the flower head full of seeds is a diffuse blend of seeds with no clear rotation lines, or let's say 3 or 4 spiral arms. It's more of a diffuse spiraling pattern on sunflower. And that's the case here, with M63, and why they named it the Sunflower Galaxy. It's about 29 million light years away. It's a magnitude 9.3 object in the sky, which means you're not going to be able to see it with the naked eye. And it would probably take a very good pair of binoculars, a large pair of binoculars, to pick it out. Even then, because of its small size, it would probably be quite difficult to see. And I definitely recommend using a telescope for viewing it. They're not sure if there's a central black hole in this particular galaxy. Most spiral galaxies do have central black holes. This one is still uncertain. They haven't found the trademark of a black hole yet within this particular galaxy. Jim?
Yeah, that's a good looking view of a galaxy. I always like looking at galaxies through the cameras a little bit better than visually, because, although it's nice to be able to look at them through an eyepiece, they just kind of show up as gray little fuzzy spots, but you can see so much more detail with the camera. And I believe there was a supernova back in 1971 that they detected in this galaxy as well. And, most galaxies are going to have supernovas and whatnot, so that's not a surprise at all. But yeah, that's kind of a relatively small scale galaxy. Like you said, it's a little bit smaller than our Milky Way. Excellent. Thank you.
A little neighbor galaxy here too, I just spotted. I'm not sure the designation on that one or how far away it is. It's certainly a lot farther away, but I don't have any information on it at this time.
Well, the object we have in front of us here is Messier number 67. It's called the GoldenEye cluster, or the Pac-Man cluster, or the King Cobra cluster. As far as King Cobra is concerned, if you look nearly a fourth to a half the way across, in the middle of the screen, there's an actual Cobra setting up in there of stars. There's probably about 8 stars that make a Cobra sitting there. So this was got the name King Cobra's cluster, even though there's a whole lot more there. It's in the constellation Cancer, which is real easy, real difficult to see even in dark sights. It was discovered by Johann Gottfried Keeler in 1779. Estimates of its age range between 3.2 and 5 billion years. That's one of the oldest open clusters in the Milky Way galaxy. The distance estimates are really varied, and typically they're 2,600 to 2,900 light years from Earth. The size of it is about 20 light years across. And as far as the age is concerned, normally open clusters have the rotational dynamics of the galaxy when they're formed. So that rotation kind of makes the stars spread out after they're formed. And this cluster hasn't. There's about 4 or 5 that have extensively long times. And that's because there's enough stars in there that their mutual gravity is holding them somewhat. And they're in kind of blank parts of the Milky Way, a little bit higher than the normal plane of the Milky Way, so they're not pulled on by other stars. There's about 1,080 solar masses in there. So that's the mass of that object is equivalent to 1,080 suns, even though they haven't been able to count them all. This is the most studied open cluster of all of any, because of the similarities of all the stars to the sun. Because of its age, the only stars that have survived have been solar mass type suns. So it looks like they can track they can track the behavior and the aging of stars that are like the sun. You might see a little bit of blue bouncing off some of the stars in there. This is a cluster that's that's got quite a few blue stragglers. What a blue straggler is that when a sun-sized star gets down to giving up its existence, its gases start to collapse due to gravity pulling them in, and all the helium it's been making up turns into carbon and oxygen, 2 extra fusion reactions. And when that goes on, it makes the star become a red. But it also causes fantastic winds to blow gases away and make beautiful planetary nebulas. But what's left behind is the carbon. The carbon forms a white dwarf that's extremely hot. Most of its light comes out in the ultraviolet, makes the planetary glow, but then eventually it becomes just a white dwarf by itself, just due to the heat. If 2 of these white dwarfs collide with each other, the nuclear reactions that happen recreate new atoms, new hydrogen out of the leftover carbon and some other protons that are inside some oxygen that's inside that white dwarf. So what happens is it recreates all of it as hydrogen again, and it becomes a new star. They're called blue stragglers because when you take their spectrum, they don't look right. They don't look like they belong with those stars. And it's because they've already died and merged and come back together. And that object was M67, the GoldenEye cluster.
Very nice looking cluster, Jim. That's a nice open cluster and a lot of good range of stars in there. Thank you.
My next object is a comet. In particular, Comet C 2020 R4 Atlas. I know that's an exciting name, but Comet Atlas will work as well. So let me bring that up for you. This is Comet Atlas, and it's a fairly bright one. Right now, it's sitting at around magnitude 9.4. So it's beyond naked eye. You can't see it with the naked eye, but even a medium pair of binoculars should be able to pull out that little bright fuzzy patch in the center there. This comet is also in the constellation of Canis Venatici. Right now, it's about 60 million miles away. It was at its closest on April 24th, but it's now starting to pull away and slowly fade out. It never really gets very close to the sun. I know there's a misinterpretation of comets that they go close to the sun. Not all of them do, and this is one that actually doesn't get any closer to the sun than about the orbit of the Earth. So it kind of whips around the sun, the Earth's distance away from the sun, and then heads back out again. The orbit of this particular comet will take it about 3 times further than the distance of Pluto. So it'll end up way out in the Kuiper Belt before it turns around in its big orbit and loops back in to once again zip around the sun. It won't be back again until the year 2954. So it's up to you whether you want to wait up for it or not. I'm not going to, but if you do, you'll be able to look at it then and see if it's the same brightness or not. I'm just kidding. There are hundreds of comets in the sky on any given evening. It's just that the vast majority of them are very faint. Typically, only a handful, maybe even 1 or 2 a year, might get bright enough that you can see them easily with a pair of binoculars. The vast majority of them are telescopic objects, and they look like just tiny little fuzzy patches in the sky. Now, this particular comet does have a bit of a tail. It's not a large one, but you can see the coma. The coma is glowing fairly brightly, and the tail kind of spreads back in this direction. You can see it clearly moving to the lower right in the image. Now, it's not moving quickly. You won't see it move. But if I came back in an hour or two, it might be up in this area instead of down here. So it's slowly moving in that direction. Now, as I was slewing over to this comet, I just happened to notice that in the same field of view, there's a couple of other objects that we can just quickly look at. And these are galaxies. The galaxy to the upper left here is called the Herring Galaxy. I'm not sure why it goes by the name of the Herring Galaxy. Perhaps someone thought it looked like a herring. I'm not sure how you could get the shape of a fish, in particular a herring, out of that, but that's called the Herring Galaxy. And the one down below this galaxy is called the Crowbar Galaxy, which I think is a good representation of it. I think it does look a little like a crowbar with that bend in it. Looks like you could pull it out of the sky and stick it on your flat tire and work away at it, doesn't it? What do you think, Jim?
Yeah, it does. And you know, it's probably got a little bit of that bending to it, maybe because it recently went through an interaction with another galaxy. It could maybe even the Herring galaxy. I don't know how far apart they are, but perhaps they interacted at some point in time.
Yeah, that's quite a distance apart, but yeah, you're right. Could have been an interaction there. Interesting.
All right. Well, thanks, Bernie. Yeah, it's kind of nice to not only get some galaxies in the view, but also in your case, get a nice comet in there too. So that's great.
So what we're looking at here is known as the Eagle Nebula, also referred to as Messier Object 16. It's about 5,000 light years away from us. And it's a large nebula. It's about 58 light years across. The nebula also is surrounding a star cluster. The cluster was discovered by Philip Chizot in 1745, who made no mention of the nebula. Charles Messier independently discovered it in 1764, and he observed some glow around the stars, so he was able to observe some of the nebulosity. The nebula was first photographed by Bernard in 1895, and that's when they first observed the nebula around it. One of the most famous things about the Eagle Nebula was actually because of the Hubble Space Telescope. Back in 1995, the Hubble Space Telescope photographed a close-up image inside the Eagle Nebula, and that photograph is known as the Pillars of Creation. If you go out on the internet and search for Pillars of Creation, you'll be able to see the Hubble photograph there. The pillars in this image are in towards the center of the image. They're small here. I don't have the magnifying power of Hubble, but they're very small structures inside the nebula there. One interesting thing about these pillars is that the Spitzer Space Telescope in 2007, using its instruments, discovered some evidence that there was a supernova explosion about 6,000 years ago that may have destroyed the pillars. But it'll be another 1,000 years before we see that difference and that change in the pillars.
Hey, what we have here is Messier 106. It's a spiral galaxy in the constellation Canis Venatici, the herding dogs. Thus the name Canis, after the pair of dogs, because there's only 2 visible stars that make up this constellation. Canis Venatici is located below the handle of the Big Dipper, near the constellation Botus, the herdsman. Those are actually his herding dogs. And with only 2 noticeable stars, and one of those dogs was named Canis, and the other one Venatici, and in mythology. The herding dogs in legend are the ones that are keeping the Big Dipper, and I mean the Ursa Major and Ursa Minor up in the sky, because before those dogs came along, they were terrorizing villages. It was discovered, this galaxy was discovered by Pierre Bouchain, Charles Messier's observing partner, in 1781. M106 is about 1/3 larger than the Milky Way, with a diameter of about 135,000 light years. It's about between 22 and 25 million light years away from Earth, so it's moderately close compared to some of the galaxies we look at. And the presence of a 40 million solar mass central supermassive black hole has been identified in the radio frequency broadcasting out of the central gas cloud around it. It's one of the largest and the brightest of the nearby galaxies, similar to Andromeda Galaxy. And that's M106, which unfortunately doesn't have a name.
Very nice. Yeah, and it's got a little bit of structure you can see there, so that's good. And
Yeah, you can see that the two the outer arms are actually spiraling away. So that actually on the lower right and the upper left, that's some of the later forming star mass.
yeah, and it definitely has a very bright central core.
Looks almost like the Black Eye galaxy on the one edge where the dust band is.
Right. Yeah.
That dust was what revealed the black hole, the supermassive black hole.
All right. Very nice. Well, thank you, Jim.
What we can see here in the middle of the screen can best be called a mess of a galaxy. It is considered to have at one time been a spiral. It's now an irregular Magellanic, means it's like large and small Magellanic clouds, Magellanic type dwarf galaxy in the constellation, again, Canis Venatici. This is only a few degrees away from the last object I showed, that was M106, and this is a few degrees away from it. It's only though 12 million light years from Earth. It's relatively close to the local group of galaxies that Milky Way is part of, but it's only 20,000 light years across. That's really a dwarf. It was thought to have formed as a spiral, but it is now a very disrupted collection of stars due to recently found smaller dwarf galaxies in the area and surrounding it. 4 of them since 2012 have been discovered. It looked like that's what turned that mess in the middle from a nice spiral galaxy into just a random collection of stars almost. It has a general bar shape in the middle, and that's all that's left of the spiral nature of it. And it's got some scattered young blue clusters in there that shows that they're still forming stars. Due to the other galaxies, the dwarf galaxies, they cause the gas in this galaxy to start to compress, and it starts making new stars just due to the presence of the dwarf galaxies around it. But it's a dwarf itself. So it's sort of like a schoolyard fight among the smaller kids. It's also a starburst galaxy because of all those stars being created. And there's a couple of clusters of star forming regions in that thing. It's creating stars in the core of that disrupted structure at twice the rate of the Large Magellanic Cloud, which is considered a pretty prodigious star generator. So that one right there is New General Catalog number 4449 in Canis Venatici.
And so, Jim, when most galaxies go through a merger process, a lot of times do they become what we would classify as irregular galaxies then, because they just lose their shape?
Depends on the nature of the collision, whether it was a glancing blow or right through the middle. They can do anything from become an elliptical galaxy, or they can become an oddball shaped galaxy. We are only seeing them now in our short life, the time we've been looking at these galaxies. But if you do computer simulations on them, it turns out they actually take a long time and many passes of each other to finally settle down into a shape. So the first step will be a disruption. But in the case of this galaxy, the other dwarfs are too small even to see with the best equipment until, like I said, about 2012, when we found 4 of them that caused the disruption. It was unknown what caused this thing that had some of the nature, like a bar in the center of it, of a barred spiral galaxy, but it's just scattered. It's just a lot of stirred up stars on the thing. So that's the joint gravitational effect of the group of dwarf galaxies around it. And since it's only a dwarf galaxy, it can't fight back.
Right. Yeah. It's they're all kind of on the smallish side. So, yeah, very cool. Well, it's nice to see and talk a little bit about how the galaxy merger process happens and what happens to different ones and whatnot. So, yeah, excellent. All right. Thank you.
My next object is a supernova. A supernova in the constellation of Draco. This supernova, it goes by the name of SN for supernova 2021 for the year HPR. And it's in a galaxy by the name of NGC 3147. This is a rather obscure, small little galaxy, far, far away. And these small galaxies, they rarely give any particular name to, like the sunflower or Andromeda. They aren't big showpiece galaxies. The galaxy itself is that little fuzzy area that you see right in the center of the image. I'm going to try to clear that up just a little bit. And we'll bring up the black level a little better. And we'll do what's called some average stacking. And that should clear it up just a bit. And you can see some spiral pattern to the galaxy now. It's faint. I don't know if you can see it, but there's a spiral arm that comes around like this and comes around down like that. So there is a little spiral structure to this galaxy. It looks like it's almost a face-on type of galaxies. These points of light are stars in the foreground in our galaxy. Wherever that rather bluish looking one right there is not a star, that's a supernova. And that supernova is a star that exploded within this spiral arm of that galaxy. This supernova was discovered by an amateur astronomer by the name of Koichi Itagaki in Japan. There's a number of astronomers that search these small little galaxies night after night, looking for supernovas. And this one he discovered on April 2nd of this year. It peaked in brightness late last month, around the 26th of April, and is now starting to dim back down again. This is a type 1A supernova, and it's around magnitude 14 or 15. So to be able to see this visually, you'd need a fairly large telescope. I can do it with a camera with my 8-inch, but I doubt very much if I could visually see this if I put an eyepiece into my 8-inch telescope. Supernovas only happen about every 100 years or so in a galaxy. And it's actually been about 300 years since we've had one in the Milky Way, 300-400 years. So we are past due for one to happen within our galaxy. However, when you have thousands, tens of thousands of galaxies up in the sky to look at, finding supernovas, even many of them every year, is very common. So there's actually a list of the many supernovas that have been discovered this year or any year on the internet if you want to do a little searching. Now this is a type 1A supernova, which is a binary star system. So there's two stars involved. One is a white dwarf star, and the other is typically a giant star, like a red giant. And the white dwarf accretes or pulls in matter from the giant star, the red giant star, and it keeps pulling in more and more matter mass from that larger star until it reaches a limit. It's a very specific limit. And when it does, it explodes. And the brightness of that explosion, the amount of energy from that explosion, is a very specific amount. In fact, it's 2 times 10 to the 44th joules of energy. If that means anything. And that specific level of energy will have a specific amount of light. So these supernovas are used as what's called standard candles. By measuring that light level and comparing it to known distances for other supernovas, they can tell exactly how far away this is. And that's the value of type 1A supernovas. They are what's called standard candles.
The object we're looking at here is known by many names. It's primarily called the Omega Nebula, or some refer to it as the Swan Nebula. It's also got names of the Horseshoe, and down in the southern hemisphere, they refer to it as the Lobster Nebula. This object is about 4,000 light years away from us, and it's about 56 light years across. So again, a fairly large nebula. This nebula was first noticed by Philip Loys de Chazois in spring of 1746, and then rediscovered by Charles Messier in spring of the same year. Messier cataloged it as M17 in his catalog. This nebula is located in the Sagittarius constellation, which is near the center of our galaxy. When you're looking towards this, you're looking towards the center portion of our galaxy. It's nearby to the Eagle Nebula. Even in small telescopes, this nebula is quite visible and is quite spectacular. The overall color of this nebula is reddish, which is showing up here in our image. This is due to hot hydrogen gas that's being excited by the stars within it. This is a rich star-forming region. A lot of the stars can't be seen because they're obscured by there's so much gas here. But they do believe it's still a very active star-forming region. Hubble has also done photographs of this area, done some zoomed in portions of the star-forming regions.
What we're looking at is, and we did look at one earlier tonight, is a globular cluster, a particular kind of cosmological object. This one in particular is called the Rose Cluster. It's Messier object number 5. A globular cluster is a tight ball of 10,000 to more than a million very, very old stars. They're in highly elliptical orbits around the Milky Way core. They find themselves about 10,000 to as much as 300,000 years, light years away from Earth. The one 300,000 light years away from us object used to be called the Intergalactic Wanderer, and it was discovered by William Herschel. And when they used the physics at the time and determined it was 300,000 light years away, they thought that nothing that far away could be associated with this galaxy. But it turned out, tracking its path, it was gravitationally linked. So it's farther out than the large and small Magellanic Clouds, but it is the farthest out of the globular clusters. In the case of this globular cluster, it's about 160 light years in diameter and 24,000 light years away from us. But its age is what's kind of surprising, 10.6 billion years old. In several decades ago, a galaxy was considered its age by the mass, the general character of the stars that were in it. But now the globular clusters that circle these galaxies are used as the age. So the Milky Way grew from, or aged real quickly from about 7.5 billion years old to about 12.5 billion because they started counting the globular clusters. There's uncertain origins of this. We kind of know that Omega Centaurus and a lot of others, probably a fraction of the ones that have been studied, do have identifiable intermediate mass black holes at the center, which gives them a fingerprint as the core of a dwarf galaxy that got subsumed by the Milky Way. And the Milky Way only has about 154 of them, but some galaxies out there, we've been able to count more than 10,000 globular clusters circling them. In this galaxy, M5, the Rose cluster, there's an equivalent to 900,000 solar masses. In more modern times, it's in the constellation Serpens is how it's identified. But really, the constellation Serpens has two parts: Serpens Cauda, the tail, and Serpens Caput, the head. And it actually is split by the constellation Ophiuchus, the snake handler. So this is actually near the head of the snake, Serpens Caput. If you want to take a look at planetarium pictures of galaxy shapes, you can see the Serpens goes right across the bottom of Ophiuchus, and in recent times they separated the snake into two parts because it was just way too long to consider as a single galaxy. M5 was discovered by German astronomer Gottfried Kirch in 1702. Charles Messier noted it in 1764 and called it for himself. William Herschel was the first one to resolve individual stars in this cluster. In 1791, he counted 200 stars. So they've been counting stars in this cluster for over 200 and nearly 230 years, and trying to get more identification. Now that you've got better astronomical equipment, you can actually get the velocities of the stars further into the core. And that's how you identify if it has a black hole in there. That's the only way to explain the velocities. And this one is M5 and Serpens Caput, the Rose cluster.
All right, thank you, Jim. That's a nice looking cluster.
My next object is a nebula complex. This is called the Rho Orpheochi Nebula Complex. It's actually not far from the star Antares in the constellation of Scorpius. So if you know the constellation Scorpius, find the star Antares, and this is to the upper left of Antares. As I said, this is a nebula complex. There's a huge cloud of interstellar gas that's floating out there at about 460 light years distant. And this dense clouds of gas and dust equal all total about 3,000 times more than the mass of our sun. So if you took 3,000 of our suns and turned it into gas and dust, that's what this cloud is. It's relatively close by at 460 light years. Because it's out in interstellar space, it's very cold gas. It's been measured in the range of 13 to 22 degrees Kelvin, which is only a few degrees above absolute zero. What's lighting up the big red areas, these reddish tinged areas, is hydrogen gas that's being ionized by embedded stars. There's infrared stars, there's probably younger stars that are emitting ultraviolet, and it's causing this hydrogen gas to emit or go into the emission phase. You can see here there's some embedded stars within the nebula. Over to the left, there's some younger stars. These are probably O or B type stars that are very bright and glowing, kind of bluish white. And the light from those stars is actually being reflected off of the background of gas, and that's called a reflection nebula. And then these dark lanes that you see here are dark nebula. Those are patches of the gas and dust that are actually absorbing light and blocking the light from reaching us. So they look like dark lanes in the sky. This particular area of the sky is right in the middle of the Milky Way. So if this big cloud of gas had not been there, this area would be ablaze with stars. Let me bring that up to a little larger view for you. You can see how beautiful this particular area is. You won't be able to see this visually or with binoculars. This does take a camera and a telescope to be able to show it with any decent level. So this is called the Rho Orphiuchi.
This object is M57 in the constellation of Lyra. It's called the Ring Nebula. It's a planetary nebula, and it was found by the French astronomer Charles Messier while he was searching for comets in late January of 1779. French astronomer Antoine Darquier de Pellepoix then independently rediscovered the nebula while following the comet, following a comet. Darquier later reported that this object was as large as Jupiter and resembles a planet which is fading, which may have contributed to the use of the persistent planetary nebula terminology for these types of objects that are at the end of life of an average sized star. This object is about 26,000 light years away from us, and it's 2.6 light years in diameter. There have been some estimates that the gases are expanding. What you're seeing there are the outer ring, which is a little reddish, is hydrogen, and inside is doubly ionized oxygen, and it's the remainder of the average size star that can't make any more elements. That's the end of its existence. When it becomes a red giant, starts blowing those gases off, and then the carbon that's left behind is so hot that it ionizes them. So it's like a neon sign moving out. It's about 10,000 years old, and it's expanding. At some estimates I've seen it's 17,000 kilometers an hour, but we still haven't seen much change in over 100 years because of that long distance it is from us. Planetary nebula are formed by hydrogen and oxygen gas expelled into the surrounding interstellar medium at the end of life of a star, up to about 8 times as big as the sun, or as massive as the sun, as it forms a red giant. The carbon that remains behind forms a white dwarf that ionizes the gases. 4 white dwarfs can be found inside the image of the, with a little more magnification and a little more intensity. There are 2 visible in the dark area in the middle, and there are 2 more in the gas ring. So what that is then a hint that there may have been as many as 3 other stars besides the one that caused this planetary nebula that reached the end of their life sooner than this one did. So this one has still got the gases being lit up and expanding. You can see the white dwarfs from other members of a cluster of stars that reach the end of their lives. The constellation Lyra, where it resides, in legend was the harp of Orpheus. We used to name theaters after that because he was an entertainer. He liked to make people happy. And it was placed in the sky by Zeus after Orpheus's death. Orpheus's father was Apollo, and Apollo asked Zeus to do something to recognize his son, who had only tried to bring joy to others. And this was placed in the sky. The constellation was placed in the sky by Zeus to remind us to bring joy to the lives of others. So this is M57, the Ring Nebula.
Yeah, and that's always a fun one to show at in-person star parties because it shows up clearly and visually in a telescope as well.
Yes, eyeballs do better.
This object is known as the North American Nebula for fairly obvious reasons. It's turned on its side. If you look to the right-hand side, you'll see what's looks like Mexico and the dark area of the Gulf of Mexico. This object is about 2,500 light years away from us. Its size is enormous. It's 90 light years across. It was discovered by William Herschel in 1786 in England. It can be seen with the unaided eye if you're in dark skies. You can see it as a patch in the Milky Way. Its outline, except for the narrowest part of the isthmus, is visible in binoculars. The nebula itself is very, very large in our sky. It is larger than a full moon. In fact, my sensor here isn't even capturing the entire nebula. It is so large. It is red. That is being caused by ionized hydrogen. One of the reasons for the shape that we see is there's a lot of dust between the Earth and this nebula, and it's that dust in between us and the nebula that's giving it this distinctive shape. So this is always a fun one to look at, seeing the Gulf of Mexico there. Again, this is the North American Nebula, catalog number NGC 7000.
This object is another of the globular clusters that surround our galaxy, and it's a rather pretty one. It's a nice one to show in summertime. It's called Messier object number 13, the Great Globular Cluster in Hercules, which is a rather grandiose name for it. It holds several 100,000 stars in the constellation Hercules. It was discovered by Edmund Halley in 1714 and cataloged by Charles Messier in 1764. About 145 light years in diameter, M13 is 22 to 25,000 light years from Earth. Hercules is named after, the constellation is named after Hercules, the Roman mythological hero, adapted from the Greek hero Heracles. It was one of the 48 constellations listed by the astronomer Ptolemy the 13th in 154 AD, and it remains to this day one of the constellations that we identify. It's one of the 88 current constellations that scientifically are recognized. Heracles was the son of Zeus and Alcmene, a mortal woman. Heracles became immortal because of Zeus being his father and endowed with superb strength. Hera, Zeus's wife, was enraged at her husband's infidelity, and while she could not kill Heracles, she cast a spell that made him go insane and kill his children. Once he realized what he had done, he visited the Oracle at Delphi to ask for atonement. The Oracle sent him to serve King Eurystheus, the king of Mycenae, for a period of 12 years. Heracles was given a series of tasks, the 12 labors of Heracles that later became the 12 labors of Hercules. The first one was to kill the Nemean lion, a beast whose hide was impervious to any weapon. After Heracles had strangled the lion to death with his great strength, he used the claws of the lion to cut off his skin, and later used the pelt as a cloak and the skull of the lion as a helmet, which both protected him and made him look even more frightening. The Nemean lion that he killed is now represented by the constellation Leo. So what we have here is one of the second biggest globular cluster we can see. We have also seen Omega Centaurus, which is about the biggest we can see because it's so close to us. But that one's pretty close too, and we get a nice view in that right off the upper torso of Hercules.